Hello and welcome to Unit 10, where we're going to see another application of IPOP in the context of social networks, the SocialVPN. So online social networks are now widely used. Facebook, Google+, and similar systems are tools that users find very convenient to discover other users and establish relationships. And they are platforms for people to connect to other people and collaborate or communicate. But they're not really networks in the sense of a TCP/IP network. They are networks that you establish and you communicate through these service providers. And this presents a problem because your communication is hindered by the kind of APIs, application programming interfaces, and the functionality that a social networking site provides. Also, there are privacy concerns that communication goes through a provider and information that you post on the provider could be available at a later point, for example, with privacy policies that change over time. So in many cases, you'd like to be able to communicate with your peers, but not provide your data to a social networking infrastructure. VPNs provide a nice capability to start thinking about social applications where you can communicate directly between peers, not through a provider that you may not be comfortable sharing information that you're concerned about privacy. So VPNs exist, but they're difficult to set up. Users don't have public IP addresses. Users don't want to set up nets and firewalls so any other user on the internet is able to access them. And typical users will not have the kind of knowledge that's needed to configure and discover these network services and VPN services manually. So, SocialVPN uses IPOP to create easy to configure virtual private networks between users who trust each other and who establish relationships through the social network provider. So here, Alice, Bob, and Carl are using the OSN, the online social network provider, to discover each other, to exchange cryptographic information, the certificates that are used to establish VPNs. But then the VPNs themselves use IPOP to tunnel messages. And unlike the group-oriented approach that we saw in the last unit, here we have a per-user VPN. So Alice, for example, determines that she wants to connect her own computers as well with Bob. And Bob connects with Carl and Alice, and it's not necessarily connected with the same set of friends that Alice does. So in essence, each user defines the endpoints that they would like to connect indirectly through the online social network, and these mappings, these connections are mapped automatically to end-to-end VPN links that are tunneled over IPOP. So that's important because from a user perspective, it's very simple. All you need to do is log into the social network provider, and as long as your peers also log in and use the same software, your computer gets a virtual network card that connects directly to your friends. And all IP packets are authenticated and encrypted end-to-end. And the configuration here is minimal. You only need to establish your friendships and log in to the OSN provider. And from the application perspective, any application that works on top of TCP/IP will work on top of this SocialVPN. So file sharing, gaming, etc. Now, SocialVPN is not the application itself. It's a framework upon which you can layer existing applications, and you can start thinking about future applications that benefit from this secure peer-to-peer communication among social peers. So the VPN that it provides is the foundation for secure applications, for decentralized social applications to be established with the mediation of an online social network provider. So traditional applications like streaming, media, sharing desktop, remote login, file sharing, cycle sharing, opportunistic computing would work in this environment. And it's also a platform that can serve as a basis for the creation of interesting new decentralized social applications, such as a decentralized microblogging system like Twitter, or decentralized file sharing with trusted peers. Internally, the SocialVPN uses IPOP as the routing core and for net traversal and to establish your private end-to-end tunnels, as we've seen. For peer discovery and certificate exchange, we use the XMPP protocol, which connects to several infrastructures that can be used as an online social network provider, including Jabber, private Jabber servers, or Google. And one of the important features that needs to be in place here is the fact that we need to assign IP addresses in a manner that works both within a private address space and without conflicting with the user's own private address space. If you think about the number of users in a social network like Facebook, a large social network, if you try to map every user to a single IPv4 address in a private address space, you're going to run out of IPv4 addresses right there. So it's not possible, and then you have to worry about the fact that these addresses may collide with the local area network of the user. So it's not possible to simply assign a static IP address to each user given the constraints of IPv4.